Hello and welcome back to the channel. A quick reminder before we begin that you should stick your phone on silent and you should close any open tabs. When I ask you to do questions, make sure that you actually do them. Okay, so in today's video, we're going to try and answer this question: what is a covalent bond? So in our previous video, we looked at how metal atoms lose electrons to become positively charged ions, and non-metals can gain electrons to become negatively charged ions. When this happens and you form positive and negative ions in one kind of area or one container, what's going to happen is that those positive and negative ions are going to be attracted to each other. And we form this attraction between these oppositely charged ions is what we call an ionic bond. Okay, a quick reminder then that this here is our periodic table. We have seen the division of the periodic table using the stepped line. I'm just going to redo that now. Quick reminder of what that is. The step line is a line that begins at the side of boron, runs down under it, and then forms this step shape like this. Now, what is this? Well, this is a stepped line that separates the table into two halves. Okay, it separates them into the non-metals on the right. So all these elements are non-metals, and we have the metals on the left. And we've seen that if we take a metal atom and a non-metal atom, we put them together, the type of bonding that they will do to combine is ionic bonding. But what happens if we just have two of these guys, two non-metals? What happens then if we just have two non-metals? Well, if they were to form ions, say oxygen was to form an ion, it would form an O2 minus ion. What if fluorine then was to form an ion? It would form an F minus ion. Well, how would these two things stick together? Well, the answer is they wouldn't, because F is negatively charged and O is negatively charged. So we know that things with the same charge, both negative charges, are just going to repel. They're not going to be attracted, so they're not going to stick together. So ionic bonding is not going to work here if we've got two non-metal atoms. So they do something different. They do something called a covalent bond. So covalent bonds are formed when we have only non-metal atoms, like two non-metal atoms. So if you ever see a substance that's made of a metal and a non-metal, or has a metal in it, then it cannot be covalent bonds. Okay, so covalent bonds only have non-metal atoms. Let's look at some examples. Here is a molecule of H2. Here is another molecule of CO2. Here is another molecule of H2O. Okay, let's look at these three things. Look at what we've got. We've got molecules because they're groups of atoms. There's more than one atom here. So H2 means two hydrogens. CO2 means one carbon and two oxygens. And H2O means two hydrogens and one oxygen. That's not new for you guys. You guys have mastered that content already. But what we do notice here is that if we look at these, just to clarify one thing, this guy here belongs with these. Okay, hydrogen stuck out on its own, and it belongs with the non-metals. I should have made that very clear, and I didn't, so I apologize. Hydrogen is a non-metal. It belongs with them. Okay, so it's out by itself because it doesn't really fit into any group, but it does belong with the non-metals. Okay, so just clarify that. That's really important. So what we have here is we have hydrogen here, we have carbon and oxygen here, and we have hydrogen and oxygen here. If we look for all of those, let's have a look. Let's highlight them. Here's hydrogen, here's carbon, and here's oxygen. They're the only ones we have so far. And as you can see, they're all non-metal atoms. So we've got atoms stuck together, so there's some kind of a bond, and they're all non-metals. So these are all going to be covalently bonded. Let's have a look at another couple. Here is O2. It's a molecule of oxygen. So two atoms of oxygen stuck together. So they're bonded together. What type of bonding? It's going to be covalent. And here is HCl, hydrogen and chlorine. Okay, so we have a new one here. We have the element chlorine. And look where it is. It's also a non-metal. So all of these molecules are going to experience covalent bonding. But what is covalent bonding? Okay, so we're going to possibly we've looked at some concrete examples of things you will have heard of. You will have heard of H2, hydrogen. You will have heard of CO2, carbon dioxide. You will have heard of water. You will have heard of oxygen. And you've probably heard of HCl, or hydrochloric acid, as we call it. All of these things are what we call covalent substances. So you have some concrete examples that you will have heard of. Let's look at how this happens. We're going to take our example of hydrogen first. So here is hydrogen. It has the symbol H. And if we check on the periodic table, it's got the numbers 1 and 1. What does this mean? Well, it means if the protons that were yellow here, representing protons with a yellow dot, they've got 1 proton because the atomic number is 1. In an atom, if they've got 1 proton, that means they've got 1 electron, because we know that atoms have to be neutral. So E, we've got 1 of these as well. The neutrons, shown in green, well, to get the neutrons, we take the mass number minus the atomic number. So in this case, it'd be 1 minus 1 equals 0. So no neutrons. That's a quick background on hydrogen. Again, there's nothing new for us there. Let's draw some hydrogen atoms. So here is a hydrogen atom. It's got 1 electron in its first shell. That's all it's got. It's only got 1 electron. Look, here, 1 electron. Okay. Let's draw a second one. Here is a second atom of hydrogen. Now, what do we know about them? We know they've got 1 electron in their outer shell, in their first shell, then they're not stable, because we know the rule. An atom needs 2 electrons for a full shell. If it's the first shell, it needs 2. It needs 2 electrons for a full shell. So what we can say about hydrogen is that it's not stable. So how can it get stable? Well, the answer is it's a non-metal, so it definitely isn't going to it's not going to form an ion. So what can it do? Well, it can do this. The 2 atoms can overlap like this. They overlap, and in the middle, they share this pair of electrons. Okay, so they share the pair of electrons. So here's the 2 hydrogen atoms, and they're sharing a pair of electrons. What does that mean? Well, they now have a share of both of them. So this atom in blue has a share of the 2, but this atom in pink also has a share of the 2. So they now have, each of them, they now have a full shell of electrons in that first shell. They now have a full shell. So together, we say they are stable. Now, they wouldn't be stable if they were on their own. They're only stable when they're together. This here, this shared pair of electrons in the middle, is what we call a covalent bond. Okay, and the reason why they stay together, they stay stuck together. Remember what's in the nucleus is the protons up here. Protons are in the nucleus. So each of these has a positively charged proton. And what's it going to do? Well, it's going to be attracted to this pair of electrons that's in the middle. Okay, so it's going to be attracted to those. So that pair of electrons keeps the nucleus of each atom attracted to it, keeps them pulled in tight to each other. Okay, now don't get too hung up on that if that idea isn't natural to you. Just know that the shared pair of electrons is the covalent bond. And notice it's a pair, it's not 1 electron. They don't just share 1, they have to share 1 each. Okay, when we look at this then, this is what we would normally see for hydrogen. We'd see it as H2. And what this 2 means is it means 2 atoms bonded together, covalently bonded. So we can now kind of clarify what we actually mean by covalent bond. So we talked about a shared pair of electrons. Shared pair of electrons. No, I'm actually going to fix that. Shared pair of electrons. So a shared pair of electrons is what we call a covalent bond. That's what it is. It's a shared pair of electrons, and it happens for non-metal atoms only. non-metal atoms only. And we know that to achieve a full outer shell, this is why atoms share electrons. They share pairs of electrons to achieve a full outer shell, and it happens for non-metal atoms only. All right, first little set of questions is going to be to look at these substances and tell me what type of bonding do they have. Will it be ionic or will it be covalent? All right, now, so what I want you to do is I want you to pause the video in a second. But before you do, I need you to get your periodic table and think about how do you know if it's going to be ionic or covalent bonding. So I want you to pause the video now and write down the 6 substances and what type of bonding they have. Do that now, please. Pause the video and do that. Okay, so you should only be watching the video if you have completed these questions. So let's see how you got on. Hopefully you managed this okay. We're looking at the first one, NaCl. Is it ionic or is it covalent bonding? Well, of course, the real question you need to do here is ask, do I have only non-metal atoms? Okay, so the first thing I'm going to look at is chlorine. Chlorine, if I go to my periodic table, just show you how I do this. Here is chlorine. Okay, I'm going to pick a different color because they're messing up. Here is chlorine in pink. So it's definitely a non-metal. Okay, so I can tick that one. Yeah, that pink chlorine, that is a non-metal. Tick. What about Na? Well, if I go to my periodic table and look for Na, I won't find it in the non-metals because it's over here. So in green, Na is over here. So Na is a metal. So that's a problem for me because metals and non-metals don't make covalent bonds. They make ionic bonds. So it's ionic. So well done if you said ionic. Let's have a look at the next one, MgO. All right, so hopefully you're realizing pretty quickly that Mg, magnesium, is a metal. So this is a metal and a non-metal. This is going to be ionic. H2o. All right, so that was one of our examples. Both of these are non-metals. So this is going to be covalent. Well done if you said covalent. Good job. CaS. Well, Ca is calcium. And calcium you will find on the left of the periodic table. It's a metal. Sulfur is a non-metal, but that's no good to us for covalent. This is going to be ionic. It's got a metal and a non-metal. CH4, well, that's carbon and hydrogen. And both of these are non-metals. So very good. I know that this is covalent. Well done if you got that one right. And lastly, HCl. This is 2 non-metals, so this is also covalent. If you got 100% right on those, well done. That means that you have mastered the idea that covalent is between non-metals only and ionic is between a metal and a non-metal. A few more questions for you to have a go at now. What I want you to do is pause the video and answer these questions. Please do that now. All right, so you should only be watching and you should only be playing the video if you have finished these. Number 1, where are the non-metals found on the periodic table? And you're going to mention to the right of the step line. To the right of the step line. Well done if you got that right. Why is H2O a covalent molecule? Why? Well, it's got 2 non-metals. 2 non-metals. So it's definitely a covalent molecule. They are going to share electrons. So when they've got 2 non-metals, they share electrons instead of transferring electrons like we saw for ionic bonding. True or false? This diagram shows covalent bonding. That would be false. Well done if you said false. How do I know that it's false? It's false because this here, lithium, is a metal. And there's other clues as well. Here I see pluses and minuses, and that suggests to me that these are ions. Okay, so how do you know? Well, we've got a metal and a non-metal, so it definitely is not covalent, it's ionic. It's a metal and a non-metal, and the other thing is that we've got ions, which means it's ionic. We never have ions, pluses and minuses, for covalent. What is a covalent bond? So it's a shared pair of electrons between what type of atoms? Between two non-metal atoms. That would be a really good answer. A lot of you probably wrote it's a shared pair of electrons, but to be a little bit more specific, I hope you can see why my answer is a little bit better, because we're clarifying, well, where do we find these shared pair of electrons? They're not just a random shared pair, they're a shared pair and are found between two non-metal atoms. Give two examples of covalent molecules. So you could have given any of the ones we talked about, things like H2O, HCl. What else could you have given? H2O2, HCl. You could have given CO2. You could have given HC. I did that one already. H2O. Sorry, H2O. Any two non-metal atoms. Okay. All right. So hopefully you got any two of those. Well done if you did. All right. Let's look. We're going to take a look at one that's a little bit more complicated now. So hydrogen was quite easy to follow. Let's look at a little bit more complicated one. Here is fluorine. Fluorine in the periodic table has the numbers 9 and 19. This means it's got 9 protons, 9 electrons, and 10 neutrons. Again, I'm assuming that you guys know how to do that by now. If you don't, you need to go back and watch the video on how we do subatomic calculations. Right here, we have an atom of fluorine. Fluorine has 2 electrons in the first shell. Here we go, here's 2, and it's got 9 altogether, which means I'm going to open a second shell. I'm actually going to turn that off because it's quite annoying. There's 1, 2, 3, 4, 5, 6, 7. There's a fluorine atom. What do we know about it? Well, it's got 7 electrons in its outer shell, and it needs 8 for a full shell. It needs 8 electrons for a full shell. It's not stable at the moment. Okay, so let's draw another fluorine atom. Because we know if it's fluorine, it's going to share electrons with something. So here's a second fluorine atom. I'm drawing it the same way, but you can see I'm drawing dots for this one's electrons to show that they're different from the other atoms. So here is a second fluorine atom. 2 in the first shell, 7 in the second shell. Both of these are not stable. So how can they be stable? Well, we've already seen fluorine. If you put it with a non-metal, it can take an electron from the non-metal. But in this case, there are no non-metals. There's only fluorine. So what does it do? Fluorine will arrange itself like this. Now, what I'm going to do is I'm going to stop drawing the inside shells just to make it a bit simpler. Okay, so I'm only going to draw the valence shell. So when I'm drawing bonding diagrams, I only draw the valence shell. So here are my 2 atoms of fluorine, and this here is the valence shell. Okay, this is the second atom of fluorine. I'm going to draw its shell first. I'm going to show that they overlap like this. And this is the second atom of fluorine. Okay, so this fluorine has 1, 2, 3, 4, 5, 6, and then its 7th one is going to go in to be shared with the other one. This fluorine also has 1, 2, 3, 4, 5, 6 electrons in its outer shell, and here's its 7th one, overlapping and being shared with the other fluorine. Let's just count how many electrons each one has. This fluorine in green has 1, 2, 3, 4, 5, 6, and it's got a share of these 2, 7, 8. That means that this fluorine is stable. Stable. This fluorine with the yellow, it has 1, 2, 3, 4, 5, 6, and now it's got a share of both of these as well, 7, 8. This atom is also stable. So by sharing electrons, they have each got a share of 8 electrons in their outer shell. This here is the covalent bond. Okay, and it's found in between the atoms, and it's very strong. It holds them together very tightly. This substance is now F2, where the 2 means 2 fluorine atoms stuck together covalently. All right, again, that one's pretty straightforward. It's just 2 fluorine atoms. We're going to make it a little bit more complicated. Let's take a look at the element or the compound hydrogen fluoride. Sorry, spell that wrong. It's F-L-U-O-R-I-D-E, hydrogen fluoride. Well, we already know that hydrogen has 1 proton, 1 electron, and 0 neutrons. We learned that when we drew it earlier. This is an atom of hydrogen, 1 electron in the first shell. This here is fluorine, F. F, as we saw in the last example, has 9 protons, 9 electrons, and 10 neutrons. And this is fluorine, F, with 2, sorry, I'm going to draw these as dots, so they're different electrons than the hydrogens. 2 in the first shell, 1, 2, 3, 4, 5, 6, 7 electrons in the second shell. So how can these are 2 nonmetals, they're definitely not going to do ionic bonding. How can these combine so that they're stable? Well, these can combine like this. I'm just going to draw the valence shell again. So here is the hydrogen atom, and the hydrogen atom overlaps with the bigger fluorine atom. This is the fluorine atom. Here is the hydrogen's electron. It's been shared with the fluorine. Here is one of fluorine's electrons that's been shared with the hydrogen. Here are the 6 other valence electrons of fluorine. Hydrogen now has a share of 2 electrons. Hydrogen only has 1 shell, so that is full now, and that means that that is stable. Hydrogen is stable. Fluorine, well, it has a share of these 2, but it's also got 2, 4, 6 of its own. That's a total of 8. That means it's got a full second shell. Fluorine is also stable. So this here is the compound hydrogen fluoride, like that. Sometimes you will see this written like this, H-F. Okay, this is just a different way of drawing the same thing, where the dash means a covalent bond, a shared pair of electrons. And sometimes you will even see it drawn like this, where we don't draw the shells at all, we just draw the valence electrons. So here is the 1 valence electron of hydrogen, and here is the second one in the bond of fluorine. That's one of fluorines. Here is the F, and here are the other valence electrons of fluorine that aren't in the bond. So as you can see, hydrogen has a share of these 2 that are in between, like this. And fluorine has its own 6. Here we go. Here's 2, 4, 6, and it's also got access to the shared pair, so it's got a share of 8. Okay, this is a simplified diagram. Simplified diagram. So this here is what we call, the main one is what we call a dot and cross diagram. And as you can see, why? Because we use dots and crosses to show the electrons. This is a dot and cross diagram. This one over here is a simplified dot and cross diagram. All right, we're pretty much, we're building up to harder and harder ones. Let's look at one that's even a little bit more complicated now. So let's have a look at water. Water is made of the elements hydrogen. So again, let's draw a hydrogen atom. Here's hydrogen, 1 electron. It's also made of the element oxygen. Here is oxygen, 2 in the first shell, and 6 in the second shell. Like this. Okay. Now, as you can see, or as we already know, oxygen, what does it want? It wants to get 8. So oxygen needs to share 2 electrons to get 8. Okay, it's only got 6 in its outer shell at the moment. It needs to share 2 electrons. But that's tough luck for oxygen because hydrogen's only got 1. Well, if they join together, then oxygen's not going to be stable. So that's actually not going to help oxygen. Okay, so if this is going to work, the only other way that we can make oxygen be stable is to add another hydrogen. Now we've got 2 extra electrons that can combine. So how does this work? It works like this. Here is our oxygen atom, O. It's going to share with 2 hydrogens. So here is one of the hydrogens. Actually, I'm going to need to overlap them more. Here is overlapping with one of the hydrogens, and here it's overlapping with the other hydrogen. So the hydrogen's electrons are shown with X's like this. Here's X and X. So that each hydrogen has its own electron. Now remember, a covalent bond is a shared pair of electrons. That means oxygen, one of oxygens goes in here and one of oxygens goes in here. Now oxygen has 2 electrons, 1 in each of the bonds, and we know it had 6 up here. So oxygen also has 2 more of its own pairs, or 4 altogether. Let's just count up now and see if oxygen is stable. Here are 2 of its own, 2 pairs of its own, that's 4 altogether. And then here are 2 shared pairs. So oxygen has a share of 8 electrons. That makes it stable. Each hydrogen, well, they have a share of the pair as well, which means each hydrogen has 2 altogether, and that makes them stable. This has the formula H2O, like this, H2O, because there are 2 hydrogens and 1 oxygen. This is the dot and cross diagram. Here is another way you will see it, like this, where each line represents a shared pair, and we would often then show the extra pairs up here on the oxygen, like that. Or here is a simplified dot and cross diagram where we have the oxygen, and we have, here are the 2 lone pairs, or the 2 pairs that oxygen has of its own. And then here are where it's forming the 2 bonds with the oxygen, so with the hydrogens. Here are the hydrogens' electrons, like that. We might often see it drawn like that. That's a simplified dot and cross diagram. All right, so there's lots of different ones of these that we can do, and we will see more as we go along. But I think for now, what it's time to do is for you guys to practice doing some of these. Okay, so here are some questions that I want you to do. I want you to draw the dot and cross diagrams for these. I want you to be careful when you get down to number 10 and don't get caught out. Really look at it closely. Okay, there's a reason why I have a star beside it. See if you can find what it is. So pause the video, get your copy out, answer the questions, and only play when you're finished. Okay, so you should only play it if you're finished and you've practiced all these questions. Hopefully you found them okay. Draw a dot and cross diagram for a hydrogen molecule. Well, a hydrogen molecule just has hydrogen. So that would be this. 2 hydrogen atoms, and they're sharing their pair of electrons. And the formula, question 2, is H2. So well done if you got that right. Formula here, as you saw, is H2, and it's drawn 2 hydrogen atoms sharing 1 pair of electrons. Draw a dot and cross diagram for a chlorine molecule. Now you saw me doing fluorine before. Chlorine will be very similar. And remember, we just want to draw the valence shell. We don't need to draw the inside shells, just the valence shell. So here is your chlorine molecule. So here are 2 chlorines, okay, and here they are sharing a pair, and each of them have then 7 of their own, okay. So they have 7 of their own. Oh, sorry, I actually made a mistake there myself. They don't actually have 7 of their own. They've got 6 of their own. That was silly because they've got 7 altogether. Okay, so I've made a mistake myself there. There we go. Now that's better. Okay, so they've got 6 of their own, and then they've got a shared pair of electrons in the middle. Okay, so if I said they had 7 of their own, like I had made a silly mistake, I just wasn't thinking when I did it, that means that they would have 9 altogether, and that's too many. So they only want to have 8. So they've got 6 of their own, and they've got a shared pair. Okay, so the formula then is Cl2, 2 chlorines. Well done, you got that right. The next one, draw a dot and cross diagram for an oxygen molecule. All right, let's have a look at oxygen. This is what you should have up here. Okay, so oxygen is going to be 2 oxygen atoms, and notice that this time they have to share 2 pairs. Okay, so actually, do you know what? I think I need to probably show you how to do this one. Okay, so we've got 2 oxygen atoms like this, O, and here is 1 oxygen, and here they are overlapping. Here is the other oxygen. Now, each oxygen has 6 electrons. That means that they need to share 2. They need to share 2 electrons each. Okay, so here are just going to zoom out a little bit. 1, 2, 3, 4, and they're going to share 2. So that means here 2 of this oxygen's electrons have to go in here. This oxygen has 1, 2, 3, 4, and it had 6 of its own altogether, and it has to share 2, which means I've got to put 2 of the electrons in here. Now, as you can see, altogether there are 4 electrons being shared in here. So this oxygen has these 4 and 1, 2, 3, 4. So that's made that one stable. This oxygen has 1, 2, 3, 4 in the middle, and then 2 and 4 more, 8 altogether. So the formula is O2. Okay, so well done if you're able to get that by yourself. If not, then hopefully that makes sense to you there now. Okay, and the best way to think about it is to draw it out first of all, just by itself. If you're struggling with this idea, draw it out. Here's oxygen. It's got 6 electrons in its outer shell. We know then that that means it needs to share 2, which is why we have to put 2 of its electrons into the bond, into the overlapped area, because it needs to share 2. It has to share 2 as well. So 2 of its electrons have to go into the space. Right, let's look at the next one. It says the formula of methane is CH4. So 1 carbon attached with 4 hydrogens. Draw a dot and cross diagram for methane. Okay, so methane, this one was again quite a challenge. So well done if you did get this one right. Remember, starting off like this before we actually look at the final example. If we look at carbon, when we draw carbon, we'll see it's got 1, 2, 3, 4 electrons. If it's got 4 electrons, then it needs to share 4. It needs to get 4 more, so it needs to share 4. So that means all of its electrons have to go into bonds. Okay, all of its electrons have to go into bonds, because if it needs 4, then it needs to share its 4. Okay, and it does that like this. It overlaps with 4 different hydrogens. So the X's here are showing carbon's electrons. Here's the 4 electrons of carbon, and the dots show the electron of each hydrogen. So each hydrogen gets a share of 2, and altogether the carbon gets a share of 8. So CH4 is the example. Right, the next one was draw a dot and cross diagram for carbon dioxide. Carbon dioxide is CO2. This is what that one will look like. Again, using the same method I've shown you, carbon needs to share 4. So as you can see, it needs to share all of its electrons. So here are carbon's 4 electrons. The four dots are carbon's electrons. So, here we go. Here's 1 of carbon's electrons, this dot. Here's another one, here's another one, and here's another one. 4 dots are carbon's electrons. Oxygen needs to share 2, so each oxygen will share 2 electrons. As you can see, this oxygen is sharing these 2, and this oxygen is sharing these 2. So all together, just count up. You can always count them up at the end and make sure each atom has 8. Okay, so this carbon has these 4 and these 4. So the carbons have 8 altogether. The oxygens, if you count them out, should also have 8. They've got 4 of their own, and then they've got the 4 in the bond, which is 8. So CO2 is the formula. Well done. And lastly, what is the chemical formula for calcium chloride? Well, this is a bit of a trick question. I hope that you spotted that this here has a metal in it. So it's not going to be covalent bonding. This is going to be ionic bonding. And we've done this already. The formula for calcium chloride, calcium's in group 2, so it's going to form a 2+ ion. Chlorine is in group 7, so it's going to form a 1- ion. So to balance it out, we need another 1- ion. We need 2 chlorines. Will give me the formula Ca, 1 of those, and Cl2, 2 of those to balance out the charges. Well done, if you got that right, great job. Okay, so I know today's video was a challenge, okay, but I do encourage you to stick with those diagrams, okay, and if there's something you don't get, go back and watch again how I did them, okay, because they're really important. It's an important skill to be able to do. All right, guys, that's it. Well done, and I'll see you in the next video. Thanks, guys. Bye.